is the one I'm worried about. Adding and subtracting fractions. And the problem here is people, it's not that they don't know how to add and don't know how to subtract fractions. It's just that they get it confused, like the laws of integers. When you add them, you do certain things. When you multiply them, you do other things. The same thing happens with fractions. When you multiply them, it's real easy. You just go straight across the top and straight across the bottom. When you're adding, you're looking for a common denominator. And what happens on test day is I'll ask you to multiply two fractions together, and you will go looking for a common denominator, and you get the rules all messed up. So that's what makes it really difficult. So let's talk about adding and subtracting fractions. If we have a over b plus c over d, here's a weird question, and I know you're not going to be able to answer it. But why do we need a common denominator to add and subtract fractions? Why do we need a common denominator to add and subtract fractions? Why are we forced to do that step first?
Because it's the rule.
I know, it's the rule. It's what you were taught. But did you ever learn why?
Because they didn't say like you can't add and subtract two different. It's like my teacher taught me apples and oranges. You can't add like.
Well, that works for like variables x and y. You can't add. That's what I got apples and oranges.
Well, that's what she did. Apples and oranges.
This is how you learned it way back when. Grade school. Here's a pie. Here's a pie. And this pie is cut into 3 slices, so it looks like a peace sign. And here's a pie that's cut into 4 slices. And you want to know how much of a pie do you have left if you have one piece of each of them left over. So the problem is the pieces are different sizes, therefore you have to make the pieces exactly the same size. And you have to cut them in such a way that you can have them as equal slices. So you would cut this one into 12s, and you'd cut this one into 12s, and you'd have, this one would get divided into 4 equal pieces. And this one would get divided into 3 pieces. And now these 3 pieces are the same size as those 4 pieces, and 4 plus 3 is 7, it would be 7 12s. But that's the elementary school way of doing it. There is another underlying reason why...
We're okay with elementary.
Oh. But there is another reason why you need a common denominator. And this is the mathematical reason. Let me write this down first. If you have 1/4 plus 3/4, we know that's equal to 4/4, right? Which is equal to 1. But another way of writing 1/4 is 1 times a quarter. And another way of writing 3/4 is 3 times a quarter. Agreed? You all see that, right? Because 1 times a quarter is a quarter, and 3 times a quarter is 3/4. What's common? The quarter. So what can I do with the quarter? I can kick it out, factor it. So if I factor out the quarter, you get 1/4 times 1 plus 3. What property is this? Distributive property. And 1 plus 3 is? 4. And you get 1/4 of 4, and which is, of course, 1. So this idea of common denominator is actually pulling back to the distributive property. You need those denominators to be exactly the same so you can pull it out, add the 2 top numbers together, and then put the denominator back. And that's why you need the common denominator, because it is the distributive property. So let me go back to my little AB plus CD. What's the common denominator? The way I think about it is, what's missing here that the other side has? A D. Now, if I multiply the bottom by D, I also have to multiply the top by D. Why? Right, but what's D over D? 1. And 1 times anything leaves it alone. So the quality is not changing of this. Over here, what's missing? The B, top and bottom. Okay. So then we get our AD over BD plus, well, it should be BC over BD, the D. Now the BD is common. We generally just write it as one fraction, but this step right here is the same thing as factoring out the 1/4 over here. By writing it only about the only term on the bottom, you have technically factored it out. You pulled it away from the 2 terms. And what's left is AD plus DC. And that's how you add fractions. And or subtract them. The plus sign and minus sign really doesn't matter. So this is the technique that we're going to use just for adding and subtracting fractions. And it doesn't change. It's common denominator, what pieces are missing, you put them in top and bottom, both fractions. So if I give you a simple one, 4 over 8x plus 4 minus 3 over 4x plus 2. And I say this is a simple one, except for one problem. I put this one on my college algebra test, and they all get it wrong, which is amazing. I find it amazing. Well, because they take this and they say, well, what's missing on the left-hand side is 4x plus 2. And right away, that just makes things horrible. And I mean in a bad sense. What should you do to the bottoms first before you even decide what's missing?
Make them even.
No.
Pull out the GCF.
Pull out the GCF. See what they have as pieces. So what's the GCF of the first term? 4. What's left behind?
2x plus 1.
2x plus 1. What's the GCF of the second one?
2.
2. What's left behind?
2x plus
2x
1.
plus 1. When you get it into factored form, you can see better what pieces are actually missing. For instance, if this is a 4 and this is a 2, is there anything missing on the left? No, because this is 2 times 2 and it already has one of these. They both have 2x plus 1, so that's definitely not missing. So the only side that's missing something is the right-hand side. What's it missing?
2.
A factor of 2. So you're going to give it a factor of 2. But if you put it in the bottom, you better put it in the top. And it has to multiply the entire top. In case there's pieces of it, it has to multiply the entire top. What's that? Oh, did I do 3? I did, because I saw the 3 there. 2. Okay. You're awake. So, the next step is, once you get your common denominator, just write it once. It doesn't matter which side you write. If you put the missing pieces in, they're exactly the same. So you write one fraction. The common denominator is 4 times 2x plus 1. And you write it exactly once, because technically you factored it out. What's left up top? Well, that one didn't change, so that's still 4. Minus 3 times 2 is 6. 4 minus 6 is negative 2 over 4 2x plus 1. All right. Are we done?
No.
No. 2 and 4 have a common factor of 2. So you'll cancel them out. This goes into 2 goes into 2 once, 2 goes into 4 twice. So you get negative 1 over 2 times the quantity, 2x plus 1. And that's the simple one. Or at least what I think of as simple. So when does it get bad? Well, technically they don't get any harder. They just get a little, well, messier. That's about all I can do to it is make it messier. So for example, let's go up one step. 4 over x minus 2 minus 5 over x plus 2. Yeah, x plus 2, that'll work. First step should be, can you factor the denominators? Who cares about the numerator in this case? When you're multiplying and dividing, you factor everything. When you're adding and subtracting, you only concentrate on the denominators. So can you factor x minus 2 or x plus 2? No. So they're factored out, and here's a strange question. What factor is missing on the left that the right has?
-1. You don't you multiply by -1 to make the sign?
No. See, if you multiply this by -1, it becomes negative x plus 2. That's not the same. That's x minus 2, or x plus 2. So what factor is missing on the left that the right has? The x plus 2 here. Why is this x plus 2? I mean, when we were dealing with the a's, the b's, the c's, and the d's, the denominator was bd. One from the number from the left fraction and the number from the right fraction. So when you're looking at this, these long fraction bars, remember they represent grouping. So the factor that's here is x minus 2. And this long fraction bar over here is a grouping symbol, and this factor over here is x plus 2. So now when I ask what factor is missing on the left that the right one has? X plus 2. It has to be the whole thing. So you're going to multiply this whole bottom by x plus 2. But if you multiply the bottom, and I'm going to put it next to the 4 over here, just to be, normal. You usually put the 4 and then the factor. Over on the right-hand side, what's missing? The x minus 2 factor. So I'll put that in here. But if I put it in the bottom, I'm going to put it in the top. Now, the next step to reduce the number of mistakes that I know that are going to happen one way or the other, please follow this step. I know you're not going to want to, but if you don't, you're going to make a silly mistake. Create the common denominator, which is x plus 2, x minus 2. Just pick one of them, the left one, the right one. It really doesn't matter which one you pick. And then copy down the top exactly the way it looks. The problem is, this minus sign is kind of low, and a lot of people don't see it. So if you copy it down exactly the way it looks, you'll get rid of, hopefully, one of the mistakes that are extremely common. So this negative will come up here. It's 5 times the quantity, x minus 2. It seems like a wasted step, but trust me, if you skip this step, you will make one mistake. And that mistake is usually right here. Negative 5 times negative 2 is positive 10. Up here, if you were doing it, you would catch the negative, because you would write the negative down and then go 5 times x is 5x, and you'd have the negative 5x. But then you go 5 times negative 2 is negative 10, and your sign would be off. So it's better to write it all down so you can see that the negative 5 is what's distributing and not just the positive 5 part. All right, and distribute out the top. You get 4x plus 8 minus 5x.
Are we just going to distribute,
Let's
or are we going
distribute.
to cancel out?
Can you cancel? Can you cancel with this sitting up top? No, not when there's subtraction, unless it's contained in parentheses and it separates it into terms. You can't do any canceling. It has to be one entire term on the top, one entire term on the bottom. And by the way, if you did cancel, probably what would happen is you kind of start writing it down like you did at the beginning. So it kind of gives you a hint. All right, so distribute 4x plus 8 minus 5x plus 10, all divided by x plus 2, x minus 2. Another big mistake is people think that they stop writing the denominator because all you're doing is copying the denominator over and over again, that they'll get the right answer. What happens, though, is once they stop writing it, they never bring it back, and they'll have the numerator correct and no denominator, and I have to mark it wrong. So you gotta, I would highly suggest you keep it with it. 4x minus 5x, 8 plus 10, and it's over x plus 2x minus 2. And there's our answer. It's not hard, it's just a matter of concentration from the beginning to the end. Make sure that I don't get much harder than what they give. And let's do one other. Don't care about that, don't care about that. Ooh, here's a good one. This is number 12. 7 over x squared minus x minus 6 plus 5 over x minus 3. Let's discuss the headaches of this one first. If you by chance mistakenly factored x squared minus x minus 6 into x minus 3 and x plus 2 or x plus minus 2, x plus 3, whatever it is. Or I'm sorry, x minus 6 and x plus 1. Maybe you chose that by mistake. This one is x minus 3, and it would be missing both of these factors. I would never give you a problem where you have to multiply by 2 binomials, because that makes a weird, ugly, horrid mess. So I'll never ask for that. So if you have this one sitting here and x minus 3 sitting here, guess what one of these factors has to be? X minus 3. It doesn't have to be, but for our purposes, it will be, because otherwise it's just horrid. So when we factor this, it's going to be 7 over x factors of 6 is subtracted to 1, negative 3 and positive 2. And this is going to be plus 5 over x minus 3. Now, if you need to, I highly suggest, since this is a grouping symbol to begin with, put the x minus 3 in a set of parentheses. And that way you can see it as one term. A lot of people see the minus 3 separate from the x, and you really can't pull them apart that way. What's missing on the left that the right has?
X plus 2.
What's missing on the left that the right has? Nothing. Don't put anything over here, because it's not missing anything. What's missing on the right that the left has? The x plus 2. So you're going to put it in the bottom. But if you put it in the bottom, you also have to put it in the top. Then I highly suggest you just copy down what's there. So we have in the bottom x minus 3, x plus 2 is the common denominator. Technically got factored out. What's left on the top is 7 plus 5 x plus 2. 5 times the quantity x plus 2. And then distribute the 5. So we'll get 7 plus 5x plus 10 all over x minus 3, x plus 2. And then lastly, combine like terms, simplify the expression. Very rarely in addition do you cancel things out. You're usually introducing them. So we get 5x plus 17 all over x minus 3, x plus 2. There is a small possibility that there will be a factor in the top that will cancel with a factor in the bottom. But it's a very, very small possibility. Usually when you get to the end, that's all you can do. But look for possible factors at the top and see if any of those factors will cancel with the bottom. But again, that is very rare, unless it's a very special setup. This isn't hard, is it? Not yet. Well, the technique doesn't change. It's the same technique for every problem. Oh, I better cover one of these. This is 18. I consider this the easiest type problem. I find it kind of boring, but for some reason people look at that and go, I don't know what to do. If you put 5 over 1, that gives you at least a head start. Looking at a constant number is different than looking at a fraction. All right, so once it's 5 over 1, and you contain the 7a plus 3 because of that grouping symbol, it makes life a little bit easier. What's missing on the left in the denominator that the right has? Nothing. You can put 1 if you want. Yeah, you can put 1 here, but is it going to change anything? No, but it's good stuff. What's missing on the right that the left has? Yeah, I always found these to be easier. You just multiply top and bottom by 7a plus 3. And then simplify. So the bottom is 7a plus 3. And the top, you're going to get 15 plus 5 times the quantity, 7a plus 3. And don't cancel. No canceling when you addition and subtraction. All right, and then play around with the top. See, this is 15 plus 35a plus another 15 all over that 7a plus 3. And of course, 15 and 15 is 30, so you get 35a plus 30 all divided by 7a plus 3. Now, 35 and 30 have a common factor. Okay. 35, you can pull out a 5, what's left behind? 7a plus 6, which is really close to 7a plus 3, but does that help us? Can you cancel anything? No. They have to be identical. So, whether you left it here, or whether you went one step further and factored out that 5 is irrelevant, they're both the right answer. So I don't care which one you write it as. If you could find a common factor in the top and pull it out, that's fine. If you leave it alone and realize that it really doesn't cancel with the bottom, that's fine.
What
You-
about just like dividing like the 35 by 7 8 and then the 30 by
You can't do that because of these plus signs. Remember, with the idea of cancellation, you have to have all multiplication in the top, all multiplication in the bottom. Can't have any addition and subtraction. More horrible than that. That's more horrible. Oh, that's strange. I'll just make up one. The worst I could make it. Let's see. X minus 3 over x squared minus 5x. Trying to come up with a good one. Plus 14 minus x plus 2 over x squared minus 4. I hope that works. I'll find out in a second. Oh, make this x plus 3 up here. X plus 3. There we go. All right, what should we do first? Factor the bottoms out, so we got in the top x minus 3. Factors of 14 that add up, oh, dang it, that subtract up to 5. I gotta make that a minus 14. So this becomes x and 7, x and 2. What kind of 7? Negative and positive 2. Okay. And on the other side, we get x plus 3, and in the bottom, x minus 2, x plus 2, the difference of perfect squares. Okay. Most people are actually very good at this one, even though it's messier than some of these other ones. They see this and it makes a lot more sense. What's missing on the left that the right has? X minus 2. I'm going to put it in the bottom. When I put it at the top, what do I have to do, though? What's one step that's kind of missing? What do I have to do to the top? I got to put the x minus 3 in parentheses. It's got to be grouped. Again, this grouping symbol comes into play, and you have to group that. So that's x minus 3. We put x minus 2 in the bottom. We better put x minus 2 in the top. If you don't put those parentheses, it's just the x that's distributing. Or if you put it on the other side, it's just the negative 3 that's distributing. You want to say that x minus 3, the whole thing is multiplied by x minus 2. All right, same thing on the other side. This grouping symbol is going to contain the x plus 3. What's missing?
X minus 7.
X minus 7. Top and bottom. And this will get a little messy. So our common denominator is x minus 2, x plus 2, x minus 7. Doesn't matter what order you write them in.
No.
Nope. Commutative property, you can flip around multiplication any which way you want. Now the top, I'm going to leave it alone for now. X minus 2 times x minus 3 minus x plus 3, x minus 7. Before you go to the next step, where's the mistake going to happen? That minus sign is going to mess up a lot of things. So, multiplying these two together, no big deal. I highly suggest you multiply these two together, ignoring the negative sign completely. Because if you start bringing that negative sign into the foiling of the last two, you're going to make some horrible mistakes. So get the answer for the first two, get the answer for the second two, and keep them inside of parentheses. Keep them safe. So x minus 2 times x minus 3 becomes x squared minus 5x, it'll be minus 2x and minus 3x. Negative 2, negative 3, plus 6. Minus whatever comes next. Whatever comes next. And then multiply x plus 3 times x minus 7. So you'll get x squared minus 4x, don't forget the x, minus 21. And then this is all over x minus 2, x plus 2, x minus 7. Okay. What should I do with that negative sign? Distribute it. Now I'm going to use a little shorthand notation. Different color. The negative is going to become positive. The x squared is going to become negative. The negative 4 is going to become positive. And the negative 21 is also going to become positive. So I went through and changed all the symbols. The one on the outside and all the ones on the inside. And now I can kind of ignore all the parentheses. X squared minus x squared. Nothing. Negative 5x plus 4x. Negative x. And then positive 6 plus 21 is plus 27. All over x minus 2, x plus 2, x minus 7. And there's your answer. Now, which one would you rather do? Multiplying and dividing or adding and subtracting? Multiplying and dividing. Me too. Because adding and subtracting takes time and there's too many places for mistakes. So, what one do you focus on? Adding and subtracting. So therefore, what do you screw up on? Multiplying and dividing. You're having some troubles over there. So let me give you one and we'll see how you do. Where? 3x plus 2 over x squared minus 9 minus x plus 1 over x squared minus 5x plus 6. It's identical to the one that's to the left here. None of the steps change. You can see what you put in.
I did that right there.
See, this one is x minus 3, x minus 6. This one is x minus 3, x plus 6. What is this one? This one there.
X minus 2.
X minus 2. So you put it in top.
Yeah.
And my answer is
Steal my answers.
Yours, I heard.
Yeah.
You got an 8.
He's
I
She
got
got a
it.
4. So we got a 7.
no,
and
he
a
got
4.
we got 8.
8.
Oh, you both have 8?
We got the same number.
She's got 7.
I see. I got minus 7. He got minus 3 plus 1. He got plus 1. That'd be 4x.
Plus 4x plus 1.
We all
Alright, we're
different.
ready for your answer.
You ready for my answer? Doesn't look as easy as when I do it is.
Shut it down.
If you factor the bottom, this is x minus 3 and x plus 3. If you factor this bottom, it's factors of 6 that add up to 5, which are 2 and 3. And it's negative 2 and negative 3. And then when you ask what's missing on the left-hand side that the right-hand side has, what's it missing?
X minus 2.
The x minus 2. So you put it in the bottom. Before you put it in the top, though, contain the 3x plus 2 in parentheses, and then multiply it by x minus 2. Whatever you multiply at the bottom. All right, what's missing on the right-hand side that the left-hand side has? So you put x plus 3 in the bottom, and then contain the top first, and then put x plus 3 in the top. All right, so far so good? Okay. Fraction bar. Put in all your factors, x minus 2, x minus 3, x plus 3, and in the top, x minus 2 times 3x plus 2, minus x plus 1, x plus 3. This is where the mistake is going to happen. That minus sign causes people headaches, so you have to go a little slow when you get to that part. The first part is easy. Just FOIL that out, and you get 3x squared. Let's see, that gives you positive 2, that gives you negative 6. Negative 6 plus 2 is negative 4x. And then finally, negative 2 times positive 2 is negative 4. Minus whatever happens after the parentheses. So you see a minus sign there. The next thing you should do is just put a parentheses and then multiply those two together. So this will give us x squared. 1x, 4x is better known as?
What'd you say?
1x and 3x is? 4x. I said 4x, didn't I? And 1 times 3, of course, is?
Why are you doing the 4 different?
I'm just doing a quick FOIL.
Um,
The easy part is you know you're going to go first times first, which is x squared. And then you're going to take the inner and the outer and you're going to add them together. So you get 1x plus 3x is? 4x.
So you do the 2 outer ones first, and then the 2 inner ones.
I do outer and inner to add them together. And then first is easy and last is easy. But outer and inner gives you that middle term. That's the one you have to find to add together. Okay, you have to just go through the whole FOIL thing first, outer, inner, last, and then make sure you combine like terms. All over.
X plus 2.
All these factors. All right, that negative sign has to distribute, so it means it's going to change all the signs. So the negative becomes a positive. The x squared was positive, but now it's negative. The positive 4x is now negative 4x. And the positive 3 is now negative 3. So change all the signs, and that way you don't get confused about what's going on. And then lastly, you get x squared minus x squared. 2x squared. Negative 4x minus another 4x. Minus 8x. And negative 4 minus 3. All over x minus 2, x minus 3, x plus 3. So this problem all in itself pretty much goes over all of chapter 5. Factoring and multiplying and subtracting, polynomials, lots of fun. Where? Who? Now make sure for the test that you do that chapter review. Make sure you know how to do all types of factoring. Make sure you know how to do GCF.